quickly you can tell me what type of, this is on the based on the basic definition which we discussed. So what type of halide is it? Are you able to see the question? Ibrahim and Jasleen.
Yes, sir.
So tell me what type of halide is it? Can be a bit confusing also. So I will tell you a trick. Just you need to attempt, okay? So this is, there is a very simple thing which you should keep in mind is that carbon actually is bonded to, it is connected to four groups. Yeah, it is alkyl halide because there is an alkyl group, but the alkyl group is not like methyl, ethyl, okay? It is a big alkyl group. So on the basis of the alkyl group, you need to tell me what kind of this alkyl group this is for. Where the chlorine is attached, what kind of carbon is it? Is it primary, secondary, tertiary, benzylic? We have seen it in classification, if you remember. Yes, so let's do this. You have CH, okay, and CSC. Got it. And then you have CH. Just you need to keep one thing in mind is that is the carbon is making four bonds. So who all are connected to this carbon? There is one ethyl group, there is hydrogen group, there is a methyl group, which is put in the form of a branch sideways, okay, that is also connected, and this subsequent CH group. This CH group has also ethyl group connected to it, C2H5. There is one H, which is written over here, and there is a Cl. So this is the complete, that is condensed structure, and this is the more detailed structure, and that can help us to make out whether it is primary, secondary, or tertiary. Yeah, it is secondary. Exactly. So this is secondary chloride. Got it?
Yes, sir.
So I hope this is clear to everyone, right? And what about this one? Yeah, tell me. Ibrahim, can you see the question?
Yes, sir. Sir, there's one carbon which is attached to three methyl groups. Then there's CH2, which is attached to CHBr, and that is, I presume, okay, that be
CH2CHBr,
benzene.
and the
Yeah.
C6H5 is phenyl. Phenyl is that
Oh, yeah,
benzene.
phenyl. Yeah.
Okay, the carbon atom just
Yeah.
outside the benzene is benzylic. This is benzylic carbon.
Mm-hmm.
There's also
So it's a
two
benzyl group, so it's one.
benzylic and
Secondary benzyl.
secondary because it is
Second.
connected to two other on two sides it is connected to carbon atom. So it is secondary as well as benzylic. Okay.
Yeah,
So
secondary benzyl.
yeah, so this is secondary benzylic bromide. That is going to be the answer. Jasleen, I hope it is clear. Very simple question, just based on the
Yes,
classification.
sir.
But in examination, we can make a mistake. It is because in just lack of time, examination pressure, we can make a mistake. Yeah, this is also based on the classification. So what is going to be the answer? Aryl halide, alkyl halide, vinyl, and aryl. Yeah, Justine, Ibrahim, just quickly tell me. You can do much faster than this. I know, both of you.
Sir, B is 2. B is an alkyl halide. Is that right? Yeah, B is an alkyl halide.
Yeah,
And C
A,
is 1.
A is also alkyne. Okay.
Not necessarily. Oh, wait. A is also an alkyl, but A is more of a allylic halide, I think, or vinyl. But sir, see,
The
B is.
allylic, look, I will tell you the definition. If you have a doubly bonded carbon is vinyl. Okay. And carbon atom next to doubly bonded carbon, not the doubly bonded, next to doubly bonded, just next to it is allyl. That is allyl. Okay. One is vinyl, double bonded is vinyl. Okay, and allyl. Okay, next to vinyl. Okay, now tell me. So, Jesslyn, are you getting my point?
Yes,
And
sir.
directly connected to benzene is aryl, and next to benzene is allyl. Aryl, allyl, vinyl. Okay, sorry, aryl and benzyl. Okay, and allyl and vinyl. So all the things they have similar names. Okay, very confusing. So they will become clear once you do this question. So this first one is, where should I take this arrow? Yeah, Brian, Jaslyn, tell me quickly. Both of you. C and D, Jaslyn, you can do, and Ibrahim, you can do A and B. This is alkyl halide only, okay? And this is allylic carbon. Allylic is next to the double bond. Is it clear?
Yes, sir.
Yes, sir.
This is aromatic halide because the halide is directly connected to benzene ring. Aromatic means benzene aryl halide. And Jasmine, if it is not aromatic ring, if it's just the double bond, the carbon atom of the double bond is vinylic carbon. Got it? Is that clear or not?
Yes, sir.
Yes, sir.
Okay. So now I hope all the four categories are clear. If you have benzene, you can have two. Okay. Directly connected to benzene is aromatic halide or aryl halide. If it is a carbon next to benzene, that is benzylic. We do not have any benzylic halide. If it is a normal double bond, it is vinylic. These carbon atoms are vinylic. And if it is next to double bond, that is allylic. Okay. Is that clear? So what should be the answer? It should be 2, 4, 1 and 3. Is that clear to all of you?
Yes, sir.
Okay.
Mm-hmm.
Right. Now let's do another question. This is also on the basic classification, and I hope you can do it very quickly. Yeah. Just the IUPAC name. I gave a similar question in your assignment also. The confusion, all of the students get confused in just one thing and they keep on asking. You can write that one thing. Multiple bond is given more priority in numbering. Between the multiple bond halogen, multiple bond is given higher priority. You need to select the longest chain, but from where will you start the counting of the carbon atom? From which end? From the end which is giving lower number to the multiple bond. Okay, now tell me quickly. So, no, just you can, no need to solve all the 4 options in the examination. Just try to solve one of the option. Okay, and try to check the options given as answers, and you can shortlist the options which are matching with your answers, and that will save your time. Is that clear or not?
Yes, sir.
So, if I start the numbering, one, two, three, four, five. Okay. Or if I do it in this way, so which one is correct? Tell me quickly.
The red one.
The red one is correct because the double bond is getting a lower number. So it is going to be 4 bromo and 2 in,
Pentawine. 4 promo
right?
pentawine.
Yeah. This is going to be the answer. So one option, yeah. So no need to do all the options, but you can try all the option, that is. So you will have answers either option 2 or option 3. Now solve the Ibrahim. No need to solve all the options. Okay. Now if we check that
Yes, sir.
option D,
Option
we can
B,
get the answer.
option 2 and option 3 seem correct. Yeah.
Yeah, or option B also you can check. So because they are having different, and this
Yes.
difference we can gauge which is going to be the right answer. So let's check option, last option, option D. This is 1, 2, 3, 4, and 5. Okay, this is one way of numbering, or we can have numbering in this way also. 1, 3, 4. Which one do you think is more appropriate? The double bond is getting a lower number 2 in the blue one. I should start the numbering from the carbon atom. Got it? Not from the bromine. Carbon to carbon, end to end numbering. Is that clear? In the blue numbering, the double bond is coming under second position. Got it? In the red one, the numbering is, you need to take into account the first smaller number. Okay. In the red one, the double bond is starting from the third carbon atom. So I'm going to choose the blue one. Is it clear, Jasleen? Ibrahim? One,
Yes, sir.
two,
Yes.
right? So lower number for the double bond. 3, 4, and 5. This is 1 bromo, 2 methyl, 10 2 in. So this one and this one are matching, and they are not there in any of the other options. So this is going to be the answer. Is that clear or not?
Yes, sir.
So you are also going to do it in the same way. Save your time. Okay. And there's more quicker way to do to solve the problem instead of solving all 4. Okay, just check the 2 options which are unique among the 4 given options, and that will help you to shorten the time for the examination. You need to draw all the isomers. How many structural isomers are there? Structural only you have to draw. You don't have to consider the chiral carbon atom. Is it clear or not? Only structure. So I hope just try 4 carbon atom. How can you draw the structures? How many structural isomers? And how you are attempting it, that also you tell me. I will tell you a very quick way to do that. So if we have 4 carbon atoms, first think how to arrange the carbon atom. And the simplest way can be to take the carbon atom in a straight line. Got it? That is the
Yes, sir.
simplest way. And 4 carbon atom, what else in, can be the way to arrange them? This could be another way to arrange them. 3 carbon atom and 1 in the middle. You can't put the carbon atom in the side because that will make the chain as of 4 carbon only. That is same as that of the first molecule. Now the question comes where to put the Br. Okay, I can put the Br in this place. I'm not writing the hydrogen to same time. I can put the Br on the second position also. Got it?
Yes, sir.
Is it clear? What about the third one? Third and second are same. Because you are not going to count the numbering, do the numbering from this side if that side is closer. Okay, second and third and first and fourth are same. So you have only 2 options. Okay. And in this one, you can put the Br in the middle. Or you can put the Br on any of the 3 methyl groups. All these 3 methyl groups are same. Is it clear or not? They are same. Okay. So I hope this is clear to you. So you can have 2 isomers from this one. So I hope you are getting what I am doing, and that is very important. Okay, that you understand. And if there is any doubt, just little bit, you can just ask me any time. Okay, don't think twice while asking me. You can ask me any number. So these are the two from this carbon chain, and these 2 are from the normal chain. And you cannot have any other carbon chain possible because just you have 4 carbon atoms. You can try any option. Okay, so you will just have 4 as the answer. But Ibrahim and Jasmine, can you tell me what will be the answer if I ask you to include stereoisomers also? Today we discuss in today's class we discuss stereoisomers, optical isomers. So can you tell me what is going to be the answer? And this question is asking about the structural isomers only, you can see. But there is one more question which asks about the stereoisomers. You have to tell me the answer including stereoisomers also. So where do you count the stereoisomers as 2? I told you wherever you have a chiral carbon. Got it? If you have a chiral carbon like this connected to 4 different groups, okay, you will take them as 2 different molecules. Got it? I hope you can see the molecules. Okay. But if you do not have a chiral carbon, is this a chiral carbon? It is not. Got it? All 4 groups are same. So you are not going to consider it as 2 different molecules, just one. Got it? Is that clear or not?
yes,
Yes, sir.
Okay, great. So now, suppose if I ask you how many isomers will form from C4H9, including stereoisomers, what should be the answer? What should be the answer? So the answer is very simple. Wherever you have a chiral carbon, you can check it. It should be connected to 4 different groups. And that chiral carbon should be taken in 2 different forms. You will not write those forms like this one and this one. You should keep them, this image you will keep in your mind, okay? Always. Is it clear? So you will take, wherever you have a chiral carbon, consider the 2 different arrangements. Okay. You can consider the 2 different arrangement as you can see. So which molecule? This is a chiral carbon. No, it cannot be chiral because it is connected to 2 hydrogen which are same. Yes, this can be chiral because it is connected to 4 different groups. Can this be chiral? No, because it is connected to 3 methyl group which are same. Can this be chiral? No. So this will be one, this will be one, just one, this will be just one. Why these 2 molecules will be 2 molecules? The chiral form 2 non-superimposable mirror image because this is a chiral carbon. Got it? So if the question asks me that total number of stereoisomers, include total isomers including stereoisomers, my answer will become, it will become 5. Got it? It will not remain 4 because one of the isomer was optically active. So I have taken it as 2. Ibrahim and Jasmine, are you getting what I am trying to explain?
Yes.
Will you be able to do it in your NEET and JEE examination?
Hopefully, sir.
Yes. Okay. Any doubts in this? When to consider the molecule as 2 and when to consider it just a single molecule? Wherever you have a chiral carbon, consider 2, and if they ask you that you should count the stereoisomer, then only you should take it as 2. Otherwise, you can take it as just 1. Got it? Is that clear?
Yes.
Yes, sir.
Okay, great. Jasleen, is it clear?
Yes, sir.
Yeah, you can do the same problem in homework also. You can write it. Okay. This is the same problem. Just you can try it and let me know the answer in the next class. Because I am not doing it because I want you to do it. How many dihalogen derivative? Propane, you need to connect 2 Br atom or 2 chlorine atom. Okay, 2. So how many dichloro derivatives of propane you can form? This you can try it in homework on your own. Let me know the answer. Got it? Should I move forward to the next question?
Yes, sir.
Okay.
Sir, are there four dihalogen derivatives?
And this is propane. So either you can have one. Look, I'm not drawing. I'm writing in a short way by just putting 2 dot on one carbon in 1. Both the chlorine are on 1. Both the chlorine 1 2 dichloropropane. Okay. You should also save your time by doing the problem in this way instead of writing the complete structure. Okay, 1 and 3. Jasleen, is it clear what I am doing?
Yes, sir.
Okay. 2 and 2. Both the chlorine can come on the middle carbon. Okay. And what else? Should I consider 3 and 3? 1 1, 2 2, and 3 3? Should I consider this? Jasleen, tell me. Ibrahim, tell me. Should I consider this isomer? Yes or no?
Won't it be the same as the first one?
Yeah, it is same as that of first one, just 1, 1 and 3, 3, because if you flip it like this, it will become this.
Yeah.
So I should not consider it. Yeah. So how many isomers you are getting just in total? New unique isomers, structural isomers. The structural isomers you are getting 4 structural isomers. And if you consider the optical isomers also, this will be optically active because you have a chiral carbon in the middle, one chlorine, one H, one CH3 and one CH2Cl. So if you want to take into account the chiral carbon also, got it? So then you will have this, you should consider as 2. So total you will have 5 isomers if you consider optical isomers also. Got it? In isomers also, but otherwise structural isomers are just 4. Right? So just you can try it. Let me know. This is the next question. It was there in the NEET and very easy question. Just it is asking about the type of reaction. What type of reaction it is. It is based on the definition of reaction, how to categorize the reaction on the basis of what is happening in it. There is a substitution reaction in which one group is replaced by another group. There is addition reaction in which the 2 groups go and get attached to the double bond. There is elimination where the 2 groups are completely eliminated and there is a double bond in place of those 2 groups. So which option is going to be the answer? Correct answer. Just tell me quickly. This is quite simple. Just on the definition of the types of reaction. Yes. Ibrahim, Jasmine, tell me quickly. The first one is
Sir, first one is substitution.
Substitution.
Bromine is substituted by alcohol, OH group.
first
No, wait,
one
no,
is
no, no.
substitution.
That's B. Okay, okay. I thought B was the first one. Okay.
So can you show the
Uh,
reaction?
The
Elimination.
first one
so
is
first one is elimination. A is
yes,
elimination.
yes, Jasmine, Ibrahim, both. Yeah, okay. Second one
B will
is
be, as I said,
Then substitution.
B will be substitution. Yeah, B is
yeah,
substitution.
Then
one
last
group is
one
What's
is
replaced by
C?
another group.
elimination.
C is
C
also
is
substitution. A, number 1.
is it substitution?
So will it be addition?
Addition
No,
reaction.
wait, it isn't substitution. It's addition. Yeah, it
Yeah,
is
it is
addition.
addition.
Number 4.
Addition means 2 groups go and add to a double bond, and double bond changes to single bond. And when 2 groups get removed, you have a double bond. That is elimination. Addition and elimination are reverse of each other. Got it? So answer is A is elimination, B is substitution,
Fourth
and
option.
C is addition. Yeah, fourth option is the right answer. Correct. Good. This I gave you in very simple reaction, and you need to tell me the name also. I gave you in the assignment also. Ibrahim, Jasmine, tell me quickly what it is. Halogen exchange reaction. Yeah, Ibrahim, tell me quickly. Jasmine, halogen exchange means one halogen is exchanged by another one. What is the name? Which is halogen substitution? Halogen exchange. That
X
is
is the halogen. X will be the halogen. Yeah.
X is halogen. X is the general way to represent any halogen.
So first
And
one is halogen
yeah,
exchange.
first
First one
one
is
is
halogen.
halogen substitution reaction, and that is the specific name for this reaction is Finkelstein reaction. Got it?
Yes, sir.
It is
Yes,
single
sir.
strand. The second one is addition of HX, which could occur in the Markovnikov or anti-Markovnikov way. And the third one is the preparation of alkyl halide from alcohol, and HCl plus ZnCl2 is Lucas reagent. Okay. And the fourth one is actually the preparation of aromatic halides by electrophilic aromatic substitution, which we discussed yesterday, day before yesterday. I mean, is it clear? So first one is the answer. Jaslyn, is it clear or not?
Yes, sir.
Okay, good. This is very easy question, but very important. There are some questions which are very, very important. We can't neglect them. Tetrachloroethene and tetrachloromethane. Tetrachloroethene and tetrachloromethane. Yeah. Tell me quickly. This is tetrachloroethene. Okay, there are just three groups. And if you divide 360 by 3, the bond angle is roughly 120 degrees. Got it? Is it clear? And if you have a tetrachloromethane, it is like this, all Cl. So this bond angle is 109 degree 28 minutes. Is it clear? Or 109.5 degrees. That is the angle of methane.
Okay,
Is it
sir.
clear or not?
Yes, sir.
Okay. And that was planar double bond. The angle is 120. This is the reaction related to the halogenation of benzene. So last class we discussed, Ibrahim was there, that just let me say few words, Justine, that for alkyl halides, you take sunlight and Br2. If you want to get connected, get connected to the benzene, you don't take sunlight. You take a Lewis acid catalyst, which is FeBr3. FeBr3 break the Br2 into Br minus and Br plus, and that Br plus get attached to the benzene.
Okay, sir.
Okay, so that's what I discussed. But in the benzene, all six positions were same because benzene was circular, there was no group. But as I was discussing with Ibrahim in the last class, that if you have some group present, you need to know with respect to that group where the Br is going to come in. That you need to. Got the point? So now you have to tell me, Ibrahim, can you see the question?
Yes, sir.
So tell me where you are going to put. And what methyl is, methyl is ortho para directing group. You can write. It increases the electron density at the ortho and para positions. Ortho position, suppose if you take this methyl, okay, the first ortho positions are the positions which are adjacent to a group which is present. So if you take this methyl, the blue one, these are the ortho positions with respect to methyl. And this is the para position. And if you take another methyl, this is also ortho-para-directing. Anything which you have not understood, which you want more detail, you can ask me. Okay, is this clear?
Yes, sir.
Yes, sir.
Why
Yes.
why the methyl is ortho-para-directing? Just I can give you a brief hint that methyl there are CH groups, and these CH groups actually get into the benzene. They get involved in movement of electron with the benzene, which is known as hyperconjugation, and this brings the negative charge at the ortho and para positions with respect to the methyl, and that is where the any electrophile which you are attaching, it is going to go and attach itself on the positions where you have more negative charge. And because you took Br plus, okay, the Br plus can get attached easily to the places where you have more negative charge, and these are the places where you have negative charge due to the blue methyl and the red methyl. So both are same. I just highlighted in different colors to make you understand. Okay. So all three positions are equally electron rich. Okay, that is same. But there is one thing which you need to keep in mind, that put the don't attach the group. Here the electrophile is Br plus, because Br minus is being taken away by FeBr3. So never attach the group in the middle of the two groups. This is the least likely to happen. What could be the reason? Though the charge density is there, but this is going to be least likely. Why? It is the most difficult to happen. Reason is clear. You have two methyl group on the sides. What they are doing? What they are causing? Justine and Ibrahim, tell me. They are creating more. What should I say?
What's
They are creating these two methyl. I am telling that position which is placed between the two methyl group is least likely to get
because of more steric influence.
Steric hindrance.
yes, steric hindrance is going to be maximum. So never prefer this position, okay, for your substitution reaction. Got it? So now you can answer the question. First, you need to choose these positions which are marked, and out of these positions, you need to reject the middle position. Okay. So A cannot be
I'm
the answer.
guessing it C. Is it C? It has to be C.
Yeah, third option C is the right answer. Correct. Got it. So because you are not forming that A is problematic, this one. This is the least likely to form because of the statement. Okay. So in B also that is least likely to form. The second option. In D, the problem is you are attaching Br somewhere else where you do not have electron density. This is
Yes, sir. Meta group.
this
Meta,
is
yeah.
meta.
Meta group.
So that also cannot happen because the Br is electron donating group and it increases the electron density at the ortho and para position. Meta is not that rare. Got it? Just I hope you understood. And this concept is going to be used in a lot of other reactions. Okay. So let's do this problem. This is chlorination with 3 moles in the presence of heat or light that we discussed earlier. What is toluene? What it means? In the options, you need to keep an eye on the options also. Got it? So that you don't go wrong. So what is toluene?
Sir, toluene is benzene with methyl group, yeah?
Yeah, methyl benzene.
Yeah.
So first of all, you need to consider this kind of a molecule with benzene and methyl outside. So are you taking Cl2 FeCl3 or are you taking Cl2 heat or light? Because I am asking because both will lead to different kind of reactions. So both are chlorination. This will happen on the benzene ring. At ortho and para position, just now we discussed methyl is ortho-para directed. Because FeCl3 is a Lewis acid, it has vacant orbital. I have put a box to represent it. It will take away the Cl minus. And you have Cl plus and FeCl4 minus. This Cl plus will go and get attached to the ortho and para positions on the benzene. But if you take heat or light, the Cl2 will break into Cl radical. The Cl radical will break the hydrogen and the C carbon radical will break the chlorine, and so on. The reaction will keep on happening and you will end up with this. But when you take 3 moles of chlorine, it will happen again and again. So you will have this CCl3. Is it clear? So now the picture has changed, entirely it has changed. Methyl was electron donating group. So it was having a negative charge at ortho and para positions. But with 3 chlorine atom attached to the carbon, the picture has entirely reversed with respect to electron donation. Now this CCl3 is a strongly electron pulling group. Electron pulling group, electron withdrawing group are meta-directing. Got it? So now the electrophile, whatever you are taking, that is going to get attached to the meta position, because plus is not going to get attached to the plus, but the plus is going to get attached to the minus. Are you getting a point? So this has become up to this point. Is it clear, Jasmine? Is it clear or not? If anything is not clear, just talk anytime. Okay. I have many ways to explain. Okay. So I will explain it to you in the way in which you want. Okay. And this is meta directing. Just write electron withdrawing groups are meta directing groups. So you will have a Br being connected at the meta position Br. And this is zinc HCl actually causes the reduction of CCl mode. Zinc is giving electrons and the HCl is giving H plus. So electrons in H plus, what will happen? These Cl are going to break apart one by one. Electrons are going to come in on the carbon atom and you will have H connected to the carbon atom. So ultimately it will form CH3. But if I have reduced, this is reduction reaction. But if I have reduced all the three chlorine atoms, why I have not reduced the bromine? That is the question. I have done the reduction. Zinc HCl is a reducing agent. Are you getting my point? But why I have left the bromine as it is? Is there any reason for it? Ibrahim, Jasleen, tell me what could be the reason that I have not touched the bromine in my reaction? Yes, Ibrahim and Jasleen, tell me quickly. Yeah, what could be the reason?
Due
Yes,
to
so what's the
resonance
question?
effect.
Now, why Br is not reduced? I'm asking with zinc HCl.
Why is Br not
Not
used?
reactive with H plus or not plus 3Cl I have replaced by zinc HCl as this is the reduction.
Mm-hmm.
Why
Yeah.
not Br? Yeah, Jasleen, tell me. In today's class, we discussed what happened to this Br in substitution. So you need to do this, you
Resonance
need to
effect.
think of the same thing. Yeah. Tell me.
So resonance effect.
Pardon? Resonance effect,
Resonance
yes.
effect.
Yeah, because it is actually more strongly bonded to the benzene because its lone pair is being bonded with the benzene pi electrons.
Partial double bond is created.
Partial double bond character, so it does not be, we cannot replace it easily. But on the other hand, if you have this chlorine is not directly connected to benzene. So you will get two electrons. Okay, two electron will make it R minus and Cl minus. And then you are going to react with HCl. HCl means 2H plus. This is the RH and HCl. So this is how all the three Cl were replaced by hydrogen one by one, but not the bromine because of the resonance effect. Very clear, very good. It has partial overlapping double bond with the benzene ring, so that makes it hard to remove that Br. Okay, is it clear? So this question is very
Yes, sir.
important, bit tricky also. Okay, though it is very simple, none. The reactions given are just two or three reactions, but this is actually most of the students are not able to do this question, and this question we already did many times in Markovnikov addition. And the new thing is just one instead of H, I have taken D, the isotope of H. But the entire concept is same. Got it? Is it clear or not?
Yes, sir.
Yes,
This is
sir.
just the Markovnikov addition. Rich gets structure. So already where you have more hydrogen, that hydrogen is going to get attached. So what is going to be the final answer? Just to confuse you, I have put them up and down. Okay. But it is simple. Don't get confused by up and down position. Just you need to keep in mind where you are going to put the D, where you are going to put the Cl.
Sir, the D will be to the place with the most amount of hydrogen. Is that right?
Yeah, yeah, and where you have more
So,
hydrogens on the two doubly bonded carbon. On one you have methyl,
yeah.
another you have hydrogen.
So
Upper one you
CH3,
have
that's
methyl.
where the D.
Yeah. So that's where you are going to put your D. Okay. So what should be the answer? Just check it once more because the answer, even if you know it, the concept, you can go wrong in just examination pressure. What should be the answer?
And D will
Just
bond with CH3. So it's either 2 or 3. Is that right?
So where the deuterium is going to come in? There are two carbon atoms. Justine, are you getting my point? Okay. So there are two carbon atoms. If I can mark what is there on this carbon atom. How can it have just three bonds? It cannot have three bonds. Which is the fourth atom? The fourth atom is not mentioned. It is hydrogen. Now think of it. This is Marconi of addition. Where you are going to put the hydrogen or deuterium? It is one and the same thing. Okay. You are going to put them on the carbon atom where you already have more hydrogens. Got it? Justine, are you getting my point or not?
Yes, sir.
So tell me what should be the answer, Ibrahim?
Uh-huh.
Three.
Rich will become more rich. Rich gets richer. Deuterium is same as hydrogen.
Oh, it's the same as hydrogen. Okay, okay, okay,
Yes,
okay.
because it is written it is an isotope of hydrogen. So deuterium
Mm-hmm.
is just same as hydrogen. Okay, same atomic number. Just one neutron is more. That's it. But that is not going to change its chemical properties because neutron is inside the nucleus. So where you are going to put the D? Justine, tell me. Ibrahim, tell me quickly.
So
On the carbon
D
atom.
will. So I'm pretty sure that D will go to the CH3 group, won't it? Because yeah.
This is actually this. How many hydrogen this carbon is having? How many hydrogens are there on this carbon? Justine, tell me. There is no hydrogen at all because one side you have methyl, another side you have a ring, and another side you have a double bond. So if you do not have any hydrogen, can you see it clearly? So if you do not have hydrogen, should I put D in this place?
Yeah.
What was the statement of Markovnikov rule? Just try to recall. Doubly bonded carbon atom. Don't think of this. Here you do not have any hydrogen. So where the D is going to come in? D is going to come in where you are having more hydrogens. This is the place where D is going to come in. Okay. The pi bond is going to get shifted. You are having a cation here. Cation will prefer to form on the more branch carbon because it is more branch, more electron donating, more stable cation, and the Cl minus is going to come and get attached to the. So negative part get attached to more branched position, or you can remember in this way, whichever you like. Negative part of the addendum. negative part is attached to the more branched carbon. The upper one is more branched. Is it clear the Markovnikov rule and the H plus will attach itself to the less branched carbon? Ibrahim and Jasleen, tell me quickly.
Yes, sir.
Clear now? So now tell me what should be the answer. First, you should try to check where the Cl is connected to the more branched carbon. It is in this case, this is wrong. This is also wrong. This is as per what we are thinking. The Cl is being attached to the more branched carbon, but there are more carbon on three sides. And where the deuterium is going to get attached, deuterium is going to get attached on the adjacent one. On this one. Okay. It is put like this, okay, in the vertical position. So this should be the right answer. In this case, why this is wrong? First one, because you have both hydrogen. When you are putting deuterium, you should put D, not the H. You should put D as the symbol. Is it clear or not, Ibrahim? Tell me quickly.
Yes, sir. Clear.
Jaslin,
Yes.
negative part on more branched carbon. Negative part where you have a stable carbon atom. And
Okay,
H on less branched, where you have less carbon, put H on that. Okay. Right? So let's continue it on the next turn. Okay, and I hope these are very basic questions and very good questions also. And most of the student actually, because of the structure, they make mistake. Okay, because D, H, S, B, okay, up and down positions are just shown to confuse you. So don't get confused by that. Have clarity in your mind where to put the Cl, where to put the H or deuterium. Got it? So let me